Hello, and welcome to Hawk Mountain Sanctuary's Home Discovery Series. Today's program is Trapping and Tracking with Bracken Brown, Hawk Mountain's naturalist and biologist.
Hello, everyone.
My name is Jamie Dawson. I'm the Director of Education at Hawk Mountain Sanctuary, and thank you so much for joining us today. Hawk Mountain is the world's very first refuge for birds of prey, and we continue to work hard to be leaders in raptor conservation, science, and education locally and globally around the world. Hawk Mountain is a private nonprofit, and membership is the lifeblood of our organization. To all of our members, thank you so very much for your continued support. And if you're joining us today and you're not a member, we hope that you consider becoming one in the future. Hawk Mountain hopes that everyone remains safe and healthy during these times of COVID crisis. And we are so excited to offer our community a variety of free virtual programming. As always, Hawk Mountain greatly appreciates any donations. Just so everyone is aware, today's program is being recorded. The video will then be accessible on Hawk Mountain's YouTube channel as a continued resource. We also have a link on our website directly connecting you to our YouTube channel. At any point during today's program, viewers may submit questions through the Q&A feature on your Zoom platform. We've designated time at the end of the program to take some questions from the audience. And we are so excited that Bracken Brown is joining us today to share with us some of his field experiences and to teach us about some of the methods that scientists use to trap, track, and study wild raptors. Before we get started, I'd like to share some of Bracken's history with our audience. Growing up in the valley below Hawk Mountain, Bracken was fortunate to be given the opportunity to funnel his love of birds into collecting data for science. From the age of 6, he has been volunteering primarily with Hawk Mountain and has held field positions that have led him to witness many migratory corridors, the species they host, and the researchers who follow them. With an eye on the sky, Bracken is always excited by the challenges and their solutions in collecting and presenting scientific data. Bracken, what sparked your passion for birds and inspired you to become a biologist?
Yeah, so I'm fortunate, or I consider myself fortunate in that I've had this love of birds since before I could actually hold a memory. My family tells me I evolved from playing with dinosaurs to chasing down the birds at the farm. So that was a natural segue, and when I was fortunate enough to get to volunteer with Hawk Mountain scientists, that really focused my passion and drive for birds into promoting research and collecting data. So that was an excellent avenue that allowed me to get started both young and continue to pursue my passion and expand it. So becoming a biologist was a natural step so I could keep working with birds.
Thank you for sharing that, Bracken. And so you grew up at the foot of the mountain, and you mentioned you started volunteering as a child. What led you to become of staff, a biologist and naturalist at Hawk Mountain? How did that opportunity arise?
It is one where Hawk Mountain has always been my raptor home base. Regardless of where I was working at the time, there would always be gaps between field seasons, and I'd find myself back on the rocks at North Lookout. I did start volunteering with Hawk Mountain, so any available time I would try to get out in the field and help them out. And this position opened it up, and they offered it to me, and it really felt like the easiest yes I could ever say to get to work with such a phenomenal organization as Hawk Mountain.
Wonderful. Well, we are so thrilled you're part of our team, Bracken. So I also heard that you have been involved with a Golden Eagle research project out in Montana. Would you mind telling us a little bit about that?
Yeah, so when I was, prior to becoming a staff member at Hawk Mountain, part of my field season was working with fall and wintering golden eagles with Raptor View Research Institute based out in Missoula, Montana. And those were just phenomenal years for me because it took me off of the East Coast flyway and I got to witness fall migration coming down the Rocky Mountain front, which is dominated by golden eagles as the main migrant you have passing your lookout. So getting to work with them, and these birds are typically coming out of the North Slope of Alaska, Canada, and filtering down into the lower 48 states to spend the winter. So part of that project was collecting blood and feather samples from these birds. We did isotope analysis, trying to figure out where they were coming from. And we also deployed some transmitters so we could track the progress of these individuals to understand this northern breeding population, which seems to be in decline from all the migration counts out there, what habitats they're using, where are they running into issues. So it was a phenomenal experience of just engaging with a different raptor research project out there.
That sounds amazing. Wow, what an experience. So Bracken, I think we're all really eager to hear more about your adventures studying wild raptors, but let's take it back to the beginning. So why is it important for scientists to trap and track raptors in the first place?
Yeah, that's an excellent and very complex question. So hopefully through this program, you will gain a little bit of perspective and understanding from it. But as our founder, Rosalie Edge, best put it, the time to conserve a species is while it is still common. And how do you go about conserving something? You typically have to know a lot about that to effectively manage and conserve it. So the tracking portion is a natural segue into where are these birds coming and going from. Everyone has the ability to look out their window and see which species are hanging out at your feeder, your local park. Have you ever sat there and wondered, where did that bird come from? I only see it for a couple months out of the year. What's it spending the other 9 months doing? Where is it going? And how is it connecting those different ecosystems? So the tracking and is a vital portion in our arsenal for just understanding a species so we can help to conserve it if necessary, protect the correct habitats, and understand the morphology or who the individual is, how it's going about its life, and what adaptations make it its most fit or successful version in the ecosystem. To do that, you have to be able to trap it so you can put on tracking devices and monitor them safely. So it's sort of a collaborative information sharing where we're gaining information as individual researchers, and then we get to collaborate and share our findings with the scientific community at large. And as a unit, the entire community grows and we learn more about these species. We can make connections. As a researcher here in Pennsylvania, I can make connections with a researcher down on the wintering grounds anywhere in South America, and together we can effectively manage and try to conserve the same species across its entire range.
Thank you. So if you want to just kind of briefly highlight, what are some of the big picture questions that you and your science team at Hawk Mountain are trying to answer with some of our main research projects at Hawk Mountain that involve tracking raptors?
Yeah, so we're always interested. I mean, the first thing you do when you meet someone new is typically introduce yourself, and then you try to share some sort of common experience, find out where they come from. So just a person to person, this is a nice way of getting to know someone. We can't understand what the raptors are saying, so we have to do this through observation. So by putting these tracking devices on them, we gain the ability to understand what habitat they use, where are they going, where are they distributing from, and you can assess for some of these longer range migrants, how resilient are they to changes in their environment. So say a bird uses the same territory year after year and it comes back and the habitat's changed, whether there's a housing development going up, logging has occurred. This bird sometimes has traveled, several thousand miles to get here. how can it adjust to these changes is one small aspect you can glean from this. And then just general responses to environment, where are they choosing to spend time, and where are they going are primary ones that we get from the tracking devices. And then through banding, you get the assisted, where are they using their available habitat, and you can share between researchers, hopefully as people re-encounter your marked birds.
Thank you so much. Really important stuff. So Bracken, can you share with us some of the different methods that you use to trap various species of raptors that are being studied at Hawk Mountain?
Yeah, absolutely. And throughout the course of today, I will be sharing some videos with you when we get to that portion of the segment. So just for those of you at home, if Zoom is hogging your internet, that might get a little laggy for you. But before we get into that, we start with banding birds. So if you're trying to track species, it works well if you're doing observations, but how do you know it's that individual, the same bird showing up year after year, or is it a different bird? To do this, you have to be able to mark it in some unique fashion. The most common way of doing that is through banding. This is a string of size 5 bands that we put on eastern screech owls for one. And if you can see through the computer, there are numbers engraved on this band, and that is a unique set of 9 numbers that only this band size has. So there's one individual that has it when we deploy it, and every time that individual is caught again, we get the data from whoever caught it, and we can now connect the dots of where is this bird going. Bird banding has been going on for a long time. In Europe, it's called ringing, and we'll get into why it's called ringing a little later. But fortunately, in Canada and North America, it's all housed through the Bird Banding Lab. So they are monitoring who's getting what bands, so we're not accidentally putting out the same bands and marking up the same individual. So these aluminum bands are the first piece that we put on a bird, if it's safe to do so. And there's different sizes, so you can band everything from a ruby throat hummingbird all the way up to a golden eagle. So you're very careful and conscientious when you're handling the bird that the bird's safety comes first. Even before your own, you need to make sure that that wild bird you just trapped is going to be handled the safest way possible without any resulting injury and reducing all potential issues that might arise. Then you put on the band, and banding works great, but that requires a researcher to catch the bird again in order to read that 9-digit number. So that doesn't always happen depending what species of bird you're working with. Some often, if you check the bird banding lab, have maybe a 3% chance of re-encounter unless the bird is found dead later in life. So this is where auxiliary marking comes in. So auxiliary marking just means in addition to this aluminum band that goes on the leg and it fits nice and loose like a bracelet, the bird will wear it for the rest of its life. We have auxiliary markers, which are just ways for researchers to increase the ability to encounter the bird. So this is known as a color band. It's number 38 here. So if we put this on a American Kestrel, which is meant to go out in the field later this year, we can then from a distance re-encounter this bird because you're not reading the 9-digit code that's unique to that individual on the aluminum band, but you can read 38 in nice large printing when it's visible. Another project we do at Hawk Mountain is our New World Vulture project. And vultures have the unique ability of deploying neurohydrosis, which means they use liquid evaporation cooling on their legs. Now, they do that through defecating or pooping on their legs. which has been shown to potentially kill off bacteria and act as antibiotic capabilities for vultures. But if you're putting an aluminum leg band on that bird, that poop would cake it up. It was deemed unsafe to band vultures on the leg. So for a number of years, some of our most common scavengers went relatively understudied because we had no way of marking them, so you couldn't determine age of birds in the wild. That changed when we began putting out patagial tags. Patagial tags, if you can see, on a bird wing, they have a flap of skin that goes across the equivalent sort of in front of our elbow. And what we do is, this is just a nice vinyl wing tag, so it's going to lie flat on the surface of the wing. You can put it over the leading edge of the vulture's wing and secure it. It's not interfering with any nerves or blood vessels. We're very careful when we place it. And when the bird flies, the tag just lies flat. Everyone can read an ear tag. These are nice, large lettering. The colors stand out on the bird's body. So patagial tags really opened up our ability to research vulture movement and get the individual identifiers down. So it's a really cool adjustment in the field that is allowing us to collect a lot of very valuable data right now. So auxiliary markings are just ways of increasing the bird's visibility so we can get more data on it without having to catch the bird each and every time we want to process it. One of the techniques, you'll see a video of this a little bit later, but this is a Vulture trap, or BC for short. If you look on top of this dome, there are a lot of fishing line nooses. And if a bird is coming down and trying to run across the trap, its chances of stepping into a noose and pulling tight and getting caught are increased. So this is just a nice method for securing the leg of a bird so you can actually trap and handle it. There's also things like using mist nets. So here's my Raptor Mist Net. It comes in a bag and you spread it out and you can see that it's a very fine nylon material here. And it's actually in pockets. So between these two trammel lines, it forms a pocket, and any bird that hits that net is going to fall into the pocket, and then it's going to act like a hammock, just holding the bird until the researcher comes and gets it. So some of our primary techniques that allow us to track and monitor the birds, and you need to know your bird species in order to catch it. So the better you know the bird, the easier, theoretically, it should be to catch. Another one, everyone who's been to a hawk lookout has probably seen decoy owls. So right behind me here is an excellent coworker. This is a robotic great horned owl. It was taxidermied from a roadkill individual. And this actually has the ability, I'm controlling through this remote control, the wings and head. So rather than relying on birds responding to plastic decoy owls, which they will, we can introduce a great horned owl that actually moves and appears to respond to the birds that are present, and that often increases the chance of actually getting them in the net, because owls and all of our diurnal raptors, they're in direct competition, and something like a great horned owl would happily visit the nest of a smaller buteo and potentially take a chick. So by putting this out in the open, the raptor thinks it has a chance to drive away a competitor, and they're more likely to fly into the mist net. Whereas if we just put mist nets up, chances of the hawk actually flying into it are next to none. So you're trying to even the playing field through understanding the bird's biology. But yeah, so those are our some of our primary methods. We'll get into that more with the slideshow. Jamie, are we ready for the slideshow? Or?
Good, yeah, let's do it.
All right, so this is where if you have other devices and slow internet, at some point these videos might drag down your connection. So here we are with trapping and tracking, and we're trying to connect the dots across the flyway for these species that sometimes are only in one location for a couple of months or less throughout the year. I have to give a shout out to King Henry IV, who in 1595 lost a peregrine falcon while he was hunting in France. And the next day, this bird that happened to have a little metal ring on its leg showed up on the island of Malta, which was over 1,300 miles away in a direct line. So this really sparked a huge interest in where are these birds going? And that spawned sort of a banding craze, or the beginning of one, over in Europe. Because the falcon had a ring on it, you can sort of say they still call it ringing birds when they're out there banding. So raptors were one of the first documented tracked individuals using banding technology. And then on the other side here, hopefully our faces aren't in the way, but it's the Stork, a nice German word, which means arrow stork. So the white stork breeds across a lot of Europe, and at the time, they didn't know where it went. But in 1822, in Germany, a stork showed up with a Central African arrow through its neck. So this bird had obviously been shot at. It survived and flew all the way back up to the breeding grounds in Europe with an arrow through its neck. So that really is an early case of connecting the dots. Where are these birds going, traveling to? Where are they coming back from? That really always intrigues people and is one of the main reasons I will always be out there in the fall watching migrants pass over. I think there's something like less than 30 file storks known in existence, but you'll occasionally see other species of bird with similar attributes. Again, when you're trapping for a specific species, you need to take into account the behavior of the bird. So you're not just going out in your backyard hoping that your target species flies over. If you're doing bow netting, which you can see the two circular bows here, this is on a leading ridge top out in Montana. So in the fall, you have winds coming up the slope, creating excellent lift, and all the raptors will just coast down that slope, heading south for the winter time. We know that's their behavior, so rather than being down in the valley trying to pull a raptor from a great distance out of its ideal wind, you just go set up your trap site where the bird can easily drop out of its wind, hopefully grab your lure, and it thinks it's going to keep flying, but then you can trap it and process it and get it right back out into the updraft so it can continue migrating south. So again, you need to understand a bit about your target species in order to effectively trap it. With our New World vultures, same thing. If we want to get individuals, you don't want to make it difficult for them to find it. So for this trap, I'd set it up near a carcass dump on a local farm. So the vultures would periodically check it out. They're expecting food to show up there. When it did, they were a little hesitant about walking into this trap. But if you can see in the right-hand corner, I'll try to get my cursor over it. This door can be lifted and it's attached to a trigger line. So when I had the feeding group of birds inside the trap, you just let the trigger line go and gravity takes over and slams the door shut and they're trapped. But you don't want to set something up like this out in the middle of the woods, say, where vultures typically aren't hanging out, because that's just going to extend your wait time. Make it easy for them. You're going to get the birds coming in. Depending how your research is set up protocol-wise, you might adjust where you're setting the trap to try to target different individuals, for example. Another great thing, so banding is great. If you re-encounter the individual, you can begin to get how old the bird is, what is average age potentially for the species. And with everyone catching and trapping these birds, you can begin to understand their molt. There were a couple instances in history where what they thought were separate species were actually different molts of the same species. So different coat of feathers, for example, saw-whet owls, a very small owl from the boreal forest, which has a range extending down the Appalachian and Rocky Mountains into Mexico. The fledgling birds look completely different from the adult birds. For a number of years, they were considered separate species until people began handling and noticed a transition where the bird was changing its feathers into the adult plumage. So you really can gain a lot of information just through taking some pictures. What I want to highlight, this is a northern goshawk. You have some retained pale juvenile feathers here that you can see, whereas the nice adult darker blue are coming in. And there's some retained scapularies up there. So you can really see the feather age. In a larger bird, this works great for the first couple years because it takes them multiple years to switch out all of their flight feathers. If you hunt for a living, you don't want to try to be flightless for a bit. Whereas something that, like a goose, is eating grass, they ditch all of their flight feathers at the same time and then grow them all back in the course of a summer. They have a brand new set. Aging them would not work as well. Here's the underside. It was a little shiny, but you can still see some differences in wear of these retained juvenile feathers versus the newer adult feathers. And northern goshawks are a gorgeous bird, so always worth studying them. So the Vulture trap that I showed you, this is a video of a modified Vulture trap. I was doing a project with Virginia Department of Inland Game and Fish, and we were collecting biological samples from raptors to use as bioindicators. Just so you can track what pollutants are getting into the system based on what that raptor is eating. So osprey only eat fish. That's an excellent aquatic indicator right there. Of course, the birds are nesting at this time when they're hanging out up in Virginia. So you need to safely be able to trap a bird as fast as possible so you can get her back onto the nest without interrupting, prey delivery from the male who's been out fishing. You never want to put chicks at risk. So this modified set is a nice high dome. The chick can't get near any of the nooses, so I know it's safe. And my added technique here was I actually put a fish in the nest. Now the female is expecting the male to deliver fish, so you'll see her sort of looking and poking around at different points. That's her trying to target the fish, and I found that increased my trap times with the osprey here. So here we have the video. The chick was very intrigued by this camera lens, something bright and shiny to peck at. And then you have the mother, which osprey there she is looking at the fish, checking out the chick, what's going on. Osprey take these very high steps when they're on our trap, and that is really good at ditching the nooses. So those leg nooses only work if they tighten up on the bird. So as we watch the scene develop here, she does eventually get caught. And I don't think the chick blocks it in our way, but this is typical osprey behavior. The female will hang at the nest. She's guarding the chicks up until they are large enough to be relatively safe in the nest and also require so much food that both the male and the female need to help try to provide for all of them. So this age, that chick looked to be about 3 weeks old. So still relatively young. The female's parsing everything off. She's caught. I'm on a boat floating off to the side. She's used to hanging around. So as soon as I see that she's caught, I can come in and retrieve the bird. So I'll be entering the screen shortly. This dome, we weighed it down with your basic workout weights just to secure it so there wasn't a chance of it falling off the nest. It wouldn't be the end of the world. Some people like to use this design with just floats on it because then the female is out of the nest. They can retrieve her off the water relatively easy. Here I am untangling the nooses off the leg. And you can see once you have a hold on the bird, and especially raptors, once you control the talons, they're not going to spend a lot of time trying to bite you, depending on the species, because their eyes are vital for being able to hunt effectively. And so typically, once you control the talons, that's their main weapon to defend themselves. So you're relatively safe as long as you know what you're doing around them. All right, so this is our mechanical owl in action. So you can just faintly see the mist net trammel lines running across here. This was targeting red-shouldered hawk down in Virginia. This is just, we knew there was a territorial bird down in the trees here. We set up in this lawn, put our decoy owl out. So watch for the bird coming in from up above. You'll see the owl moving and it should get caught pretty quick. Here comes the territorial bird. We're also using a collar and it's playing a red-shouldered hawk call to get the bird into the area until it sees the owl. And into the net it goes. That was one of the fastest captures I've witnessed. Typically they'll hang around, they know something's up, but you see once they hit the net, it restrains them. They're hanging, they can't really hurt themselves, and you can get out to the net and extract the bird and then take your samples. So this is a lot stressful for the bird than us trying to capture it a different method that might take longer or be more intrusive. We called the bird out to a region of its territory away from the nest, caught it in mere seconds. Then we had it processed and released back into the territory several minutes later. So we're not taking that much time. No trapped bird enjoys the process. If you are restrained like that, you're effectively dead if you can't get out of it. So by capturing the birds, yes, we are stressing them out, but we are trying to do it in a way that is as minimally invasive as possible, which might sound silly after witnessing something like this, but in all instances, typically the bird will get released, fly away, shake the human off, and then it returns to relatively normal. And as researchers, part of your job is monitoring and maintaining, making sure these birds aren't getting too much interference from anything you're putting on them to study their movements. So that's a vital portion of it. All right. And then the final video. So this is going to be following along with what we do with a vulture when we capture it. So we're gonna watch some clips from here and I will narrate it. This is actually Jamie, Dawson, and myself processing a hatch-ear turkey vulture that came from a local rehabber. So part of having a species that you're studying you want to collect as much data as possible from it while you have it in captivity, because this negates someone else having a question and potentially having to catch them again. You already have the data that they can use for a research question or analysis. So arts and crafts is always a useful technique. I didn't think I would need it after first and second grade, somewhere in there. But we actually do take wing tracings of our New World vultures. And what this allows us to do is use the differences in the length between the primaries, the surface area of the wing, and the weight of the bird to do an analysis on wing loading. So how much weight are they carrying around? And it also allows us to tell differences between portions of the population. So this is a turkey vulture. Everyone in North America has probably seen this bird, I hope has seen this bird. It's nice and common, but there's actually different subpopulations. So the Western birds all migrate out of Canada and fly down towards South America. They at least get to Central America. Those birds are traveling vast distances, and they actually have a skinnier, longer wing than our East Coast birds, which this is one of them, the Septentrionalis subpopulation, which they may or may not migrate. You'll see that a little later with our tracking map. So you take a bunch of morphological or body measurements as you process the bird. So here we're just doing the Kips distance, which you take the longest primary and then measure the differences in length between it and all the other primaries. And this is useful in our calculations for the wing area. I'm going to jump around a little bit. So I just said raptors, you secure the talon. With vultures, and I have the scars to prove it, you need to secure the head first. Their legs or talons are relatively weak. They don't use them, but that bill is phenomenal. They're very good at removing flesh, whether it be a researcher that's dealing with them. So definitely need to know who you're dealing with to safely restrain it and yourself. So we take a headshot. You can see that nice pale gray head of a young turkey vulture. You can see through the nostrils of it, and it still has some of that buffy color retained at the back of the head. Again, the bird doesn't enjoy the process, but we try to make it as safe and secure as possible. Newspaper mailbox is a great vulture mask taker. So thank you to your local newspaper for donating mailboxes here. And we also have that slit cut in it, and this is a brilliant design that allows us to attach the patagial tag safely with just two people without the bird potentially struggling and injuring itself or something going wrong in the process. You can securely hold it and figure out where to place the tag all the birds feel somewhat secure inside that enclosed space. So raptors, if they can see what's going on, they tend to struggle a little more. If you put a hood on them or cover their eyes, they often calm down, and it's more, I won't say relaxing, but it's calmer for the bird to go through the process here. So I'm just picking where in the patagium I want to put the tag. So I'm looking through the skin. It's thin enough. I can see blood vessels, stay away from any of the major ligaments because the wing is necessary for flying. So once you find your spot, you can line it up, and it's just like getting your ears pierced, presumably. The birds don't enjoy the sensation, but relatively quickly after being released, they're good to go. So just check that everything is sitting comfortably. And the best part, I will say, is the release. So this bird went back to the local roost, which happens to be across from the graveyard. And you can see it gets itself sorted. and then flies away back up to the roost. And now with the patagial tag, we can recognize that individual for as long as the tag is readable on it. So 485, if you see that turkey vulture, light blue tag, let us know, because we know the age of the bird, so we can collect a lot of valuable data from it. And this is just our local roost in the Kempton Valley. At this point, I think we're gonna switch to Jamie for some extra processing videos.
Thank you so much, Bracken. That was such an amazing presentation. I love watching those videos. So I also wanted to share with everyone, I happen to have here, this is a leg noose that can be used to trap vultures. So they can place these leg nooses around a carcass area, hoping that as the vultures crowd in for their communal eating, that one of them steps in the noose and then they're trapped. So I just wanted to share that. That's another method that you can use to trap vultures. So next I want to share a video actually of Bracken Brown with a banded Kestrel. But first I wanted to show a little bit more of some of the tools we use when we're banding birds. So by now we know some methods how we trap the birds, and then what are we going to do with them? Maybe we're going to band them, or we'll do a wing tag. So for banding, we use this tool. It's called a leg gauge. And so this is going to help you determine what size band you're going to use. So let's see, here I happen to have a leg of a red-tailed hawk. So whatever bird you have, you're just going to try to place it in and see which is the best fit. And as Bracken mentioned earlier, you don't want it to be too tight. You want it to be loose, somewhat like a bracelet, that it can move around a bit. And it's important that it doesn't cover any of the joints or anything to restrict movement. And then also I have some banded Raptor legs to show you as well, just to see what it looks like. You can see the numbers and see some of the different colors that are used that Bracken was talking about. All right, I'm going to share my screen. Okay, so here is a little clip of Bracken in the field talking about a kestrel that has been banded.
Hey, this is Bracken Brown, Biologist-Naturalist at Hawk Mountain Sanctuary. I'm out here in the field today with an adult male American kestrel. You can tell it's a male from this beautiful bluish coloration on the top of the head and especially the back of the wings. And then they don't have a whole lot of stripes on the underbelly. It's more these light pale colored with the spots. This bird we just trapped. It is on territory. Behind me here in that barn is a box that hopefully this bird will be occupying for the summer. So as part of our ongoing research here at Hawk Mountain Sanctuary, we have begun color marking these individual kestrels. So you can see here, this bird has a white colored band with the number 51 on it. That is unique to this individual. We are still putting USGS aluminum bands that have the 9-digit code on them that is also unique to this individual. And the point of this color band, it looks large on the bird's leg, but it is a rigid, lightweight plastic, so it's not weighing the bird down, and it's not flexing as it's moving around, so it will just ride along the bird's leg, not interfering with it too much as it goes about its business, and hopefully holds down a territory right here in the valley this summer. Why it's worth putting these color bands on with these large numerics, it means we do not have to lay hands on this bird in the future to re-encounter it. So if a biologist or someone with a camera is taking a picture of a kestrel out here in the field, they can actually pick up and detect this number, so we know what this individual is doing without people having to catch it each and every time. Whereas these USGS bands that are here for the bird's life are great for re-encounters, but you actually have to have the bird in hand or a really powerful camera and a lot of patience to actually get the entire 9-digit code unique for this individual. So we've taken some data on this bird, and we're gonna cut it loose shortly here, and hopefully it goes right back out to hunting and defending its territory and finds a mate soon. Thank you, and check in later.
Okay, so a little bit more about banding birds. I have to mention Hawk Mountain's Introduction to Raptor Field Techniques course, which is an amazing program. It's a 4-day course. It runs Thursday through Sunday, and it takes place in early to mid-September at Hawk Mountain. Unfortunately, due to COVID, we did have to cancel it for 2020, but it's planned for 2021. So if you're interested in learning more about trapping and tracking, you have to take this course to get hands-on experience. And here on the left, you can see some of our course participants practicing sizing the bands for various species of raptors before we get out to the field and we're working with the banding station. And here you can see a hawk that was trapped with a mist net, and then you can see it was banded. So that was an amazing experience, and then released. And also for our Raptor Field Techniques course, we did some vulture trapping and applied the wing tag that you can see here. So another great experience. Okay, so next I wanted to talk a little bit about radio telemetry, which is another way that you can track birds, maybe not long distance for migrations, but local nesting areas or local habitat use. So they're small, these little radio transmitters, and these are not on live birds. These photos are actually, the radio transmitters were attached to mounts of raptors that we use for our summer camp program to teach students how we do radio telemetry. But I just wanted to show the numbers. Each transmitter has its own frequency, so you know with the receiver what channel to put it on. So here's some photos of some of our campers last year from our Appalachian Adventure Summer Camp who were practicing with the antenna and listening to the audio sounds, trying to find the hidden mounts. And it was a great experience for the campers to learn how to do this. And we'll talk a little bit more about this later. Also, I know we're talking about raptors today, but I couldn't resist mentioning that, you know, radio telemetry is used for a variety of species. And last summer, Hawk Mountain collaborated with Ecology Project International to participate in a Yellowstone wildlife ecology program out in Yellowstone National Park. And I was lucky enough to be a chaperone on that trip with some local students from the Hamburg High School. So this is the collar of a radio collar for a bison that we were tracking using radio telemetry, and then this is of a wolf. So I just wanted to share that very quickly, in contrast to the size of the very small transmitter we saw on the birds, which have to be light, less than 3% of the body weight because the birds need to fly. And so that's it for now. Okay. So one of the other things I wanted to show when we were talking about banding, this other important tool, banding pliers that will help you adhere that band onto the leg. And when we were talking about the radio telemetry, I happen to have here an antenna, otherwise known as a Yagi. And to just kind of demonstrate, of course, you would also have the receiver that you're listening for audio cues, and what you're doing, you're standing in the region where you feel the bird may be, and you're listening for sounds on the receiver, a beep, and if the bird is nearby, you're standing in the right direction, it'll be louder, so that you're going to then angle yourself to go to different directions, turning all around, and you're listening for differences in the quality of the audio sounds based on what direction. And that's what you use to track the birds. So another thing I wanted to share was the satellite telemetry, which is, here's an example for a vulture. And you can see it's small, it's lightweight, it's solar powered, which is wonderful. And again, it's less than 3% of the body weight of the bird, so they still can fly. So I just wanted to share some of those things. And Bracken, I'm wondering, can you elaborate on some of the pros and cons between using radio telemetry and satellite telemetry?
Yeah, absolutely. And with any of these projects, you are limited by your resources. So with advances in technology, we have some phenomenal tools at our disposal in order to track individuals as they move across the terrain, but you might not have the resources for your project. So you have to think about what questions are you trying to answer, and is it worth, or will you get enough data from using some of these more expensive techniques. For example, as Jamie mentioned, with these new transmitters, having solar power is a phenomenal upgrade because that means you lose all of the battery weight. So it made the transmitter lighter. You could get a little smaller. We're finding for Raptors, some of the smaller end transmitters, you have the new challenge of the bird's feathers are covering up the solar panel. So what do you do? Well, in some cases, you have to go back to putting a battery on, but you can maintain a size that is small enough and light enough that it's not going to interfere with the bird's movement. But the problem with a battery is it has a limited life. So it's going to run out. Now, how you get that data is you need to take out a data plan. So for a lot of these transmitters, they're either communicating through the cell network, so pinging off cell towers, which works great if you have reliable coverage. If you don't have reliable coverage, you might want a transmitter that's going to ping off of a satellite. In both of those cases, you have to have and pay the data plan in order for you to receive the data from the bird. Or, for example, the cell tower, the bird has to be within range to communicate for long enough that it can actually download the data. With the radio transmitters, they have some now that are small enough you can actually put them on a butterfly's wing and track the migration of them. There's enough battery in it to last a couple months. But with those, you're limited by the range. That transmitter or tracker is issuing its frequency, and there's only a certain range that that frequency will travel. And you have to have an antenna within range of that transmitter to actually capture it. So if you're working with a bird, say an American Kestrel that's on the breeding ground, putting out radio tags is a great way to monitor where they are in the habitat because you can follow them around and triangulate it relatively easily. If that kestrel is migrating and you're trying to radio track it, it's not impossible, but it becomes a little more challenging. You have to have a vehicle that can stay pace with the bird. Oftentimes, depending on the species, that might be flying in a plane, using your radio antenna or receiving unit to keep up with the bird as it moves across the terrain. The term "as the crow flies" means oftentimes you can't drive alongside them effectively enough. Now, there are developments in that. There's the MODIS network that is being deployed. These are larger receiving towers that are spaced across the landscape. So it's popular with shorebird biologists right now, but we're developing or increasing the network. So many researchers are using this as an effective means of tracking their species because it's a lightweight tag. And as long as it flies within a couple kilometers of a receiving tower, it will get pinged. The receiving tower will read the tag code and we get a record of that species movement. And something like the MODIS network is phenomenal because it's increasing sort of collaboration. Typically with radio tags, I would be out there, I'm scanning my own frequency, looking for my individual tags. Something like these MODIS receiving towers, they will collect anyone's tags. So you actually get to see who else's marked individuals are flying over your area. So it's been a really cool development. And the nice thing about those is instead of several $1,000s to maintain the data plan for the tag and get those high precision points of the transmitters, you spend a couple hundred for a small tag, has a battery, will last a couple months at least. So when you deploy it is important. You'll get your data as long as the individual flies through one of these receiving towers. So it's different ways of asking or tracking the individuals. So depending on what your protocol or study is, you have to think about the cost. Cost is, at the end of the day, one of the most limiting things. It would be phenomenal. Some of these GPS, GSM transmitter units, you can set them up to ping the tower or the satellite. Now, every minute if you wanted to. Depending on what question you're asking, you can get the altitude of the bird. Phenomenal data, but you put a significant amount of money into one individual. If you're studying the entire population, that one individual's tracks are really cool, but if you can't afford to mark other individuals to get an actual flyway corridor, which we'll see next, you might not actually have collected enough information to promote your study, whereas going something cheaper, say for example, a less than $5 tag on the wing, you can, for that same $4,000, mark a lot of individuals and begin to collect the data. It's just not the same precision or frequency. So a lot of different tools. You just have to use your tools wisely and effectively to accomplish your research.
Thanks so much, Bracken. Now, can you share with us some of the things that your science team does with all this data that's collected? What does Hawk Mountain do with all this data?
Absolutely. So we'll focus more on some of these transmitters. Get to my next portion of the talk. All right, we're resuming. So just when you have the bird in hand, collect as much information as possible through measurements is a great way. If you're deploying a transmitter, here's one of our wing tag vultures that we actually recaught and decided to put a transmitter on it. That nice solar power, vultures, everyone's familiar with vultures sunning themselves in the sun. They are a phenomenal species to put something that's solar powered on it because they like to present themselves to the sun anyway. So you're should be able to maintain a nice solid charge on your device. When you've deployed the devices, you begin to collect your data. So this is from our Broadwing Hawk project currently. And Broadwing Hawks arrive in Pennsylvania typically sometime in early April, early to mid-April. And then they'll hang out here through the summer and then they leave Pennsylvania relatively early September. So that's a fairly brief amount of time to be spending up here in the north. So the obvious question is, we know through hawk counts that there's a lot of birds going through Central America, but where do our local Pennsylvania birds winter? So you can see here the names of all of our transmitted broadwings. We also had some transmitters go out in Alberta. And these are the tracks, and some of these transmitters operated for multiple years, but we found that most of our PA birds are wintering in Peru, Brazil, Colombia, Panama, Guatemala, Mexico area. So they're going deep into Central America at least, typically all the way down into South America without really making any overwater migration forays. They're sticking to strong thermal updrafts. And I have to say, a very exciting update as of yesterday. One of our transmitted birds called Rosalie, after our founder, we have been monitoring her in the project since 2014. She received one of these transmitters in 2016, and we got multiple years of following her back and forth from her wintering grounds, which one way, that's about 5,500 mile trip. So each year she's doing 11,000 miles. Last fall, her transmitter actually went dead, which is just a code for it's stationary. They call it a mortality event in Louisiana. So you always worry as the researcher that, you know, when you see the mortality events, you try to get someone or yourself out into the field to try to figure out what happened. In this case, we connected with local biologists and they went out and did a thorough search of the area. It had recently been somewhat disturbed. It was held by a paper company down there. There was a lease for the hunt club. So there was some concern that was it for Rosalie. We monitored her for a number of years, and now we captured the mortality event. Well, fortunately, Rosalie also had that aluminum band on, and we also had color bands on her other leg. So as of yesterday, we just discovered that Rosalie is back on our territory in a new nest they built this year. And from that color band, we know it's her. So she managed to drop that transmitter, which is exactly what you want. You never want an animal to be carrying a transmitter beyond the usefulness of that unit. So this is a phenomenal encounter, I'll say, because we've been tracking her for 66,000 miles of her back and forth from Peru to Corey in Pennsylvania. You can see she's following that fairly tight flight path that we have on the map here. So you really get to appreciate and understand the rigors that these individuals are going through in order to have a successful season. And they're traveling all the way up to these locations to lay eggs. So they have to be fit enough or have enough energy to lay a full clutch of eggs, sit on them, rear the young, capture food for them. So it's just phenomenal, the experiences you get to witness being a researcher out in the field, and is excellent that Rosalie is back on the sanctuary nesting for another season. So, in addition to just the sheer magnitude of how far these birds are migrating, you can begin to look at where are they stopping over to refuel while they're migrating, where are they hanging out, what are they selecting for roost sites as they're moving through. As far as the wintering grounds, are they moving around a lot down in the wintering area, or are they hanging in a small tight area, or are they coming back to the same region or selecting new regions between seasons? So all of these are valuable information that we can pull from an individual. And as you get more individuals in your study project, you can begin to get a better picture of how these birds are utilizing the landscape they travel through. This one is from all of our Vulture transmitters. It looks quite impressive because it really is the amount of data we have on this project. So you'll see that we have a bunch of transmitters on the East Coast, and those birds are staying pretty much east of the Appalachians. They only expand a little bit out, but they're staying on the eastern seaboard. Some of them go down as far as Florida or further north. Or with our transmitted vultures, we found out that a significant number of them are what we call non-migratory, which means they're not changing their habitat between summer and winter use. They actually hang out in the same area year round, and they're successful at it. So why go through changing a migratory corridor down to a wintering area if you don't have to? Birds are very efficient this way. Whereas something like our central transmitters here, they're summering up in Canada, and Canada winters and a turkey vulture do not go hand in hand. So they are what's known as an obligate migrant, which means this portion of the population has to leave. They go all the way down into Venezuela typically to spend the winters down there. So you can, from our transmitted birds, all of them left the summering area, and you see these wonderfully, fairly tight flight paths as these birds funnel down through Central America and show up on the wintering grounds. And we found that they like to winter in the same areas. So they're returning. There's an internal map to a lot of these birds. And if you're successful, why would you switch things up? So a lot of times these birds are returning to the same general areas and keeping a fairly tight migratory path as they do it. I just want to throw in, so we mentioned that the transmitters Now it's over $4,000 for a single unit, couple dollars to put out one of these patagial tags. Do you have an impact on your data set by just deploying tags versus a transmitter? Transmitters are phenomenal because you get detailed, high precision points of where the bird is. But this is for our East Coast tagged vultures. You notice right away you don't have clear defined tracks. You have a lot less encounters, but we actually have tag encounters that encompass all of the range that our transmitters travel to. So that's telling you that while this is a slower effort and it relies on citizen scientists reporting their sightings and encounters of these birds, or at least being able to read them, we are actually supporting or collecting, capturing what habitat or range these birds are using through using this low cost tracking technique. So it's a really nice support to our transmitters, and we're actually gaining this data from a higher number of individuals than what we could afford to put out through using transmitters alone. I want to leave you with an awesome video. So we have two species of vulture, the turkey vulture and black vulture on the East Coast. The black vulture is currently expanding its range north. In our area, they often outcompete the turkey vultures at a carcass. We'll see why in a second here. But you have to be able to re-encounter your individuals. So you can use motion cameras to capture pictures from the field. This is a video we're about to see. Or everyone has a cell phone in their pocket that has decent camera in it, typically. So you can capture these sightings or at least read the tags so you can submit a report, and we're gonna use that to increase our understanding of where these birds are going, connecting the dots. And you know, oftentimes we're connecting migratory connectivity, they call it. So the bird is in my backyard, it might visit your backyard, it might fly all the way down to Florida and be in someone else's backyard. But as long as everyone's working together and reporting the data, we can connect across the range of these species. So here we're gonna see that black vultures are gregarious. They hang out in large groups. They have these communal roosts. This is about 10 pounds of meat out by the roost. And you'll notice that they feed off of each other. I don't mean they bite each other in the process. That does happen. But they sort of egg each other on, and they work together as a group to pull apart the carcass. So this is very effective when you're dealing with something like a white-tailed deer, a larger carcass. Turkey vultures typically feed in smaller numbers and it's individuals at a time. So let's watch a little bit and keep an eye out for a tag. Black vultures get a bright yellow tag and turkey vultures get a light blue tag for our study. Different studies have different tag colors. So you have your first vultures on the ground and everyone else takes that as a cue and they'll rush in, and you'll see where the densest grouping of vultures are. They're working together to pull apart a carcass. They can go through a deer, a roost this size, can clean the deer carcass by the side of the road in a little over a day, if that. So they're very efficient when they're working together like this to pull apart the remains that they're feeding on. So we have this nice tight tug of war, if you would, and that work is actually working together to pull apart the carcass faster so they can feed more efficiently. We have some tags coming in now. And I mean, this is just, it is a lot of fun to witness natural behavior of these birds, not just vultures, any bird, but being able to be close enough to witness the build, how the group is working off of each other or how they're engaging with the environment is always a privilege. And it looks chaotic, but it's fairly organized. It's always centered around those bits of meat and how can they get the meat off the bone as fast as possible. I've seen them jumping up and down on skulls, trying to get to the brain tissue. So they are the complete cleanup crew. Whereas if you didn't have vultures in your area, a deer carcass would be quite the olfactory experience. So I wouldn't want to smell it for the months for it to decay. Whereas before it even begins to smell or rot, a group like this of black vultures will quickly come in, remove it, and it's gone. So really cool, exciting way to engage with your vultures. The nice thing about wing tags is if you mark enough, you can begin using this data to sort of model different aspects of the population. So population density, size, movement, using marked individuals or the mark recapture technique. You can actually begin to say how many birds are in a region roughly, or use it to support your scientific questions here. So there's no shortage of ways to use data. Everyone should be in the business of collecting the data. And as long as they're sharing it or it's getting back to the primary researchers, they can use that to further their information. So have to put a plug in. If you see a marked vulture, please let us know. I look forward to hearing from you. Now.
Thank you so much, Bracken. That was amazing. And I think it's safe to say that vultures are essential workers and such an important part of our ecosystem. Speaking of black vultures, I want to very quickly share one thing is another thing that Hawk Mountain does with some of this data from satellite telemetry is create curriculum. So we have on our website, it's free, it's Black Vulture Curriculum. And so you just go to our website under the Education tab, under Resources for Teachers, scroll down to the bottom to the curricula, learn more. And then you'll see we have several curricula, and one focuses on the movement ecology of a non-migratory raptor, the black vulture. And you can just download all the materials. It's self-explanatory. We also have a curriculum, Kestrel nest box, but also for broadwing hawks, which we'll talk about on Friday with Lori's, Dr. Goodrich's program. So this is just an example of this curriculum. It utilizes Google Earth and all of the paths that these birds, several individual black vultures take that we know from the GPS tracking, and it's all animated. It's really interesting. And then of course there's curriculum attached to it with different questions and things to follow along. So just wanted to share that. Please check that out. It's a great resource. And I just want to thank everyone. Thank you everyone in our audience for joining us today. A big round of applause for Bracken Brown for giving an amazing presentation, and what interesting and important work you do, Bracken. Thank you for all that you do. So stay tuned. As always, we have lots of exciting virtual programs coming to a screen near you soon. And this Friday, the 22nd, we have Dr. Goodrich presenting Chasing Broadwings from Pennsylvania to Peru, and that's at 4:00 p.m. Next Wednesday, May 27th, we have Raptors Up Close, Owls online with Ridgetop Rachel at 1:00 p.m. Next Thursday, May 28th, we have Sanctuary Storytime, A Nest is Noisy at 11 a.m. And next Friday, May 29th, we have Farmland Raptors with Bracken Brown once again at 4:00. So we hope to see you all again soon. Thanks so much for joining us. Have a wonderful afternoon. Bye for now.
Thanks, everyone.